Welcome you all. This is Rajiv Keti, Assistant Professor from Department of Mechanical Engineering, RIT-Hassan. Today I am going to show how to write a CNC part programs and simulation using CNC turn and milling software. Okay, this comes under CAD packages. So before starting the programming language, first we should know what do you mean by numerical control system and CNC systems. So numerical control means it can be defined as a form of programmable automation in which the process is controlled by numbers, letters, and symbols in NC, the number forms of program instruction designed for particular work or job. So for example, if you want to give any instruction using numerical control system, so we used to provide an input with the help of G codes, M codes, and by using XYZ coordinates. So this is called numerical control systems. Whereas in case of computer numerical control system, we used to have a set of microprocessors, mini computers, and logical functional programs. With the help of this, we can store the programs what we have written. Whereas in NC, we have to directly write a program and machines. Whereas in CNC control system, we can write a program with the help of computers. Then later we can dump the programs into the machines. So for any machines, the main difference is the input parameters. So input parameters means we have to define the type of dimension. So in this case, we come across with mainly two types of dimensioning system. One is absolute dimensioning system. Another one is incremental dimensioning system. So in this case, we can clearly see, so absolute dimensioning means from this reference point. Okay. So for this reference point, we used to take a value of x is equal to 0, y is equal to 0. So if you do a value, do the dimensioning from the origin to the right, the values will be positive because it comes under first quadrant. The values of x and y will be positive. In case if you want to do it in second quadrant, the x values are, for example, in x values will becomes negative and y will be in a positive value. So incremental absolute means with respect to the reference, we used to give all the dimensions. So for the better understanding, the dimensional points has been marked as P1, P2, P3 like that. So with respect to this P1, P2, P3, we should know how the dimensioning system has been done. So first, if you want to check a P1 point, a P1 is nothing but it's an origin point or a reference point where x is equal to 0, y is equal to 0. Where P2 is this one, where x is 20, y is 0. Whereas in this case, x is 70. For P3, it is x20, y20, means up to this point. So similarly, with respect to this point, we used to do all the dimensions, that is called absolute dimension. So another type of dimension system is incremental dimension. Incremental means point-to-point dimension, we can say. Means once you reach one point, then from that point, what is the second point? That dimension will be referred from previous point. So that's why it's called point-to-point dimensioning system or incremental dimensioning system. So we can observe the same coordinates we have taken for this dimensioning also. In this case, for reference point 1, x is equal to 0, y is equal to 0. Then for P2, x is equal to 20, y is equal to 0. Whereas in case of P3, just observe both absolute and incremental. In absolute dimensioning, P3 is x20, y20. So because from this point we have given the dimension. Whereas in incremental, if you want to go to P3, just observe we are already in P2. Okay. So the x value will be 0, only y will be given. That is y is 20. Next, if you come to this point, we are already in y point, that y value will become 0. Next, the x will be 50, means P4, the x will up to 50 we used to give. So like that, this is how the incremental dimensioning has been done. So we can clearly see here how the coordinate system has been shown here. So this is an origin point or a reference point to take. From this reference point, to the right x is positive, to the left x is negative. From this point, above the axis X is Y is positive, below Y is negative. So based on this condition, we used to do the dimensioning. So this is a main thing what we have to know before writing any programs. So generally in CNC part programming, we used to write an absolute dimensionings because it will be the easiest one to write. Okay, from the reference point, we used to give the dimensions. Next, we should know what are the functional codes. So preparatory functional codes, machining codes, and miscellaneous codes. So these are the codes we used to come across. In that, G codes are called functional codes. Functional code means what type of function it has to perform. For performing a function, a code will be defined with respect to, see for example, G00, positioning and rapid travel, means used to give a G00, X0, Y0 means, so G00, the positioning of the tool will take place with respect to the dimension X and Y or X and Z. For turning program, we used to take it as X and Z. For milling program, we used to take it as X, Y and Z. So G00 means positioning and rapid travels. G01 means linear, either in X direction or in Y direction or in XY direction. It will move in a linear pattern. That's why it's called linear interpolation. For if you want to write a program using linear interpolation, we have to give a code G01. Similarly, for circular interpolation, it is G02, and in circular interpolation, we come across with clockwise and counterclockwise. We used to call it as clockwise and anti-clockwise. If it is a clockwise interpolation, we used to write G02. If it is an anti-clockwise, we used to write it as G03. So G04 means dwell. Dwell means if you are writing a program at certain point, you want to give a rest to the tool. From that point, it won't take any functions. Means up to that point, we used to check the program. The dwell means giving certain time. Okay, that is called dwell. Next is this G20 and G21 are very important because these are the input parameters with respect to dimension for the machines. G20 means inch. We used to give a dimension in terms of inches, whereas in G21 we used to give a value in terms of metric or millimeter we used to define. And another one is G28. G28 means a reference point. Every machine will have one reference point. So if you want to send your tool to that reference point, we have to give it as G28. If you didn't give that G28, tool changing, everything will be can't possible. That's why G28 means a home position or a reference position where the tool will be changed. So similarly, we have all these other codes G40, 41, 42. So tool nose radius compensation, left, right, and another thing will be taken care by these things. Similarly, length of the tool compensation will be taken care by G43 and G44. After these things, we come across with drilling cycles, G73, G74. So one is peg drilling, another one is counter tapping. Tapping means creating a thread on a previously drilled holes. Okay. So we have a continuous drilling, peg drilling, counter tapping cycle, fine boring, G80 Cannon cycle, 81 drilling cycle, 82 drilling cycle with counter boring, 83 peg drilling. Okay, G84 tapping cycle, 85 boring cycles. Means all these come across drilling parameters. And another one is G90 and G91. So G90 means absolute command, means absolute dimensions. G91 means incremental, means point to point we used to give the dimensions. Generally we used to write G90. Okay. Next is G92, programming of absolute 0 point, means from the reference point to do that one. And another one is G94 and G95. So G95 means feed per minute, G95 means feed per revolution. So G98 return to initial point of a Cannon cycle, G99 return to R point of a Cannon cycle. So these are the G codes we come across. And next we come across with M codes, and we call it as miscellaneous codes or functional codes or machine codes, machine codes or miscellaneous codes we used to call. So M00 means program stop, M01 means optional stop, M02 program end, M03 spindle clockwise rotation, M04 spindle anti-clockwise rotation, M05 spindle stop, M06 tool change, M08 coolant on, M09 coolant off, M10, Y is open, M11, Y is closed. So similarly, we go through all the codes which are used for giving a values or input to machines. So G codes are functional codes. It will be perform the operation was to give in terms of X and Y, whereas M codes are the codes which are given with respect to machines. Okay. Along with this, we used to have S for spindle speed, N for sequence number, okay, T for tool change, O for program number. So we have these codes also. So next, I'll simply explain how to write a phasing cycle without using any of the things, just by using G codes and M codes. So first thing is we come across with syntax of a program. A syntax means a step of instruction which will be common for every program. Okay. In that case, first one is program name. We used to give it with respect to O, capital letter O, and any 4-digit numerical values 001, 100, 111, any values we can give, but the initial content should be capital letter O. Next is G21 and G98. So G21 means the input value. So G21 means metric system we are following. In this case, which is mm. G98 is mm per revolution. And next one is G28, home position. Okay, home position, and these are incremental values. U and W are used to give incremental values. Means at any point the tool has been stopped in a previous program. If you want to send that tool to a home position, means we don't know the absolute value where exactly the tool has been stopped. Instead of using that absolute, we used to use incremental values. Means from that point where the tool has been stopped in a previous program, from that point it will go to 00 position where the tool will be changed. Okay, so the tool changing is M06 T0101. So this is a tool pallet number and a tool position in that pallet. Okay, this 4-digit represents T0101. So this 01 is where in the pallet. Okay, generally pallet means a tool holding device. It comes with 4 tools, 6 tools, 12 tools. Okay, that's a different operating system, different mechanism which is used in a CNC machines. So we used to send it to a reference point. From that reference point, we used to change a tool. Okay, for tool changing, we used to give a code as M06 and the tool number we have to mention. The tool number is 0101 or 0201. In pallet, in which position and which tool, both we have to mention. After taking a tool, we should command it to rotate in a clockwise direction, M03, with a speed of 1200 RPM, revolutions per minute. Next, G00 means absolute rapid travel. Okay, the initial position of the tool will comes to X22, Z0. X22 means at this point and Z0. So this is a reference point. Initially, will tool come and sit in that position. If you give a command X22 and Z0. Next, we used to take a linear interpolation, means G01, and I used to give a depth of Z minus 0.5. Means from this point, I am moving in the left hand direction. Towards left, we are moving. That's why the Z value will be negative. If you are moving from the reference to right, then Z will be positive. So from this point up to this reference, the X value is positive. If you move beyond this point, the X value will be negative. So for turning program, usually Z will be in negative value, X will be a positive value. Okay, for all the programs, X is always positive, Z is negative. Okay, so G01, Z minus 0.5, feed rate of 45. So from this point, it will move 0.5 depth here, then it will move in this direction. Okay, it will remove a material and it will go back, and it will go back to initial position. Then Z will be moved for Z minus 1. From this point, it will take minus 1, then it will come up to reference point X0, then it will go back to initial position, then up to X22. Similarly, in this case, we are facing the material, means we are reducing the length of the object or length of the workpiece. That is called facing. Okay, so I'll show all these programs in a simulation once we finish this PPT, how we can execute these programs in a simulation. Okay, this is phasing cycle. Similarly, if you come to step turning cycle. Step turning means, so in facing we have moved a tool like this, okay, whereas in step turning we used to move a tool in this parameter, okay. This is called step turning. So for step turning also, first 4 programs, 5 lines is compulsory, common syntax, program number, G21, G98, reference position, incremental value U0, W0, tool change, T01, T01, then spindle start with a speed of 1200. You can give this any value. So this value will be depends on the machine specification. The maximum speed of the machine will be mentioned in the machines. Up to that speed we can give this value. Okay. Next is G00, rapid travel, up to where X30 Z1 means up to this point. Means here X30 means this reference point. Up to this point it will come and stop. Next, in a linear manner, G01 linear interpolation, X29, okay, means 1 mm depth, like it will move, then up to X40, because see, from 30 to 26 we have to remove for this first step. Next, second step is up to 28. So I can remove 2 mm for a length of 40 in a single stretch. Then later I can remove this one. So that's why we have taken a value X29. First X will move in this direction, then Z minus 40. It will go in this direction. Then it will finish and it will come back to initial position. Next X28 and it will finish its process like this and it will come back to initial position. Okay. Next, after X28, see X28 we have finished. Next is X27, means we are finished this one. Okay, we have to remove this part of the material. So for removing this part of the material, only Z is minus 20 we have to move. So X27, Z minus 20, then it will go to reference point X30, Z. Next X26 I will give Z minus 20. So I'll finish this process. Okay. After clearing this, I'll send from that point to reference position where I can change the tool. Okay, G28, U0, W0. That's an incremental value. It will go to home position or reference position. Then spindle stop, end the program. Okay, this is step turning cycle without using step turning command. Just simply using G codes and M codes. See, these two both operations, what I have shown previous one, facing cycle and step turning cycle, this can be performed using a G90 and G94 cycle. So if you use the G90 and G94 cycle, the length of the program will be reduced because we are using a standard command which will be executed for G90 for step turning cycle, G94 for facing cycle. Okay. So next program I will show that one. See, this is a manual part programming using G94 cycle because I am reviewing material like this. So we can do the facing or step turning in this manner also. So here what we will do, see this first 5 lines is common. Next G00 reference point, it will based on the tool diameter and length. Okay. So X30 and Z0. X30 and Z0 means up to this point it will come and stop. Next, see in previous case we used to take G01, X, Z, feed, every values we have to give. So what we have done here, see G94 is a box turning cycle where X means up to 10 dia, Z 0.5. Every movement means 0.5 is the facing depth we have given. It will remove 0.5 in every depth of cuts. Okay, with a feed rate of 30. Similarly, in previous case, if you want to write this program, I have to take it back to 0, then reference, then I have to give Z minus 1. So here already we have given in this line itself the J94. It's a box turning cycle. It will automatically go back to its initial position, and from that position the Z value will be minus 1. Then it will finish its cycle like this. Next Z minus 2. So in this manner it is to remove the materials. Next is up to Z10 means by removing this much of material. So the other material left is this much. Okay. So for this I'll change the X diametrical value because if I keep the same X10, it will remove all these materials. So I have to change the diametrical value here, that is X20 Z minus 3. So X20 Z minus 3 means we are giving an absolute dimension. That's why it is 2.5 for a previous, then 0.5, 3 it will be. So x20 z minus 3, then it will move like this, then it will go to reference position z 3.5, it will move like this, then it will go to reference position z 4.5, so like this. After finishing this, it will go to G28 U0 W0. Okay, so this is what it will be. I'll show all this program in a simulation. Okay, just observe what I explained. The same thing will be can be done in a simulation software. So this is a CNC manual part programming we have written using a hand. Okay. So once again, I'll go to share. So I'll share a NC program. See, this is a CAD simulation software. So we are using CNC Turn software. Okay. We are using CNC Turn software. So what we'll do here, so this is a simulation environment. Here we have to write a codes, G codes we have to write here. So for writing a G codes, so I'll copy the codes and paste it here. What are the codes I explained here? So just I'll copy and paste it here. Okay, so this is spacing operation cycle. So I'll copy this, Control C. See, I'll paste my program here. So we have to write manually because already I've just done these things. So I'll copy, paste these things. Okay. See, once we write a program, so we have to write manually programs here. After writing a program, we have to give a machine inputs, parameters, means billet size, what type of machine, okay, what type of tool we have to use, everything we have to give it here. So what I will do, so first thing, for any turning operation, we need a raw material, means blank we have to select. For that blank, click on blank. Here the length of the blank and diameter of the blank, means the maximum size we have to select. So the maximum size is, for this one, is dia 22 and length of 60. Dia 22 and length of 60. 60 length, dia 22. Give OK. So the billet will appear. Next, after taking a billet, the type of machine. So we have two types of programming languages. One is Fanuc, another one is Sinomoric. So what we have written here is a Fanuc language. So for that, I have to select a Fanuc series machines. So second one is a machine. Select a machine. Click on this one. So you will get a Fanuc one type, Fanuc type A, type B machines. So usually by default, we used to select Fanuc type A machine. Select. Okay. After selecting a machine, we have another instruction called syntax. So syntax means the program what you have written, whether it is right or wrong. The machine will check the written program is correct or not. For doing that, we have to go through this syntax. So once you give this syntax, see the number of lines and everything will be checked. So if there is any error, it used to give an error, that error will come on this side. Then we have to identify that and error, we have to rectify that. Okay. So after doing a syntax check, I need a tool to cut that material. Okay, for that I have to select a material. For selecting a tool, the dialog box will appear here and click on this tool number. Okay, then assign tool you have to click. So if I am doing external turning operation, I'll go to external turn, select an external turn and select a tool. Okay, after selecting a tool, we can edit the tool geometry, rake angle, nose radius, flank angle, cutting length, edge, approach angle, all these things parameters we can edit. These are tool parameters. So generally, if I want to get a flat face, edges, the radius should be 0. So if you have a certain radius, so that radius will be maintained at the corners of the workpieces. Okay. So for that, I used to give it as 0, give OK and OK. So this tool has been assigned and give go. So this is, we have, first I have taken a billet. After taking a billet, I have selected a machine. After selecting a machine, I have checked the syntax for errors. After syntax check, I have taken a tool. Next, I have to do the simulation. So simulation is this one. Okay. If I give the play button, it will do up to end operations. See here we used to have 3 commands. This is till end, means up to program end M30. This, if I activate this one, up to next tool, because if you want to complete any job, we may come across with multiple tools. So if you are having 2 to 3 tools, if you taken this option, after completing first tool operation, the program will come and stop here. Then once again I have to give play button. And this one is step by step, means line by line command. If you want to give, it will take like this. So I have taken an up to end of the machining, and this is the speed of the process. So keep it optimum or 50%, then give play. See here, tool has been appeared. So we are removing the material, means facing we are doing. Okay, so once it has been finished, and it will go to its home position. So I'll replay this once again, keeping in a slow motion. See, you can identify the which operation it is performing. I'll give once again play. See, first it will come to G00, X0 it has come, next G01, Z-1, okay, Z20. So like that, the depth what you have given, it is taking here. Next, after finishing, it will come to reference point, and it will go to home position. Okay, next it went to home position. So this shows the program what you have written, and the simulation is correct. Okay, similarly, I'll show, after doing this, you have to save the file, right? For saving the file, go to file, save. Okay, so in this, you select any folder or a desktop. Okay, go to desktop. In this desktop, you create your own folder, create a new folder. Okay, so the new folder I will take it as Rajiv. So in that, file name, so my file name is facing program. Okay, so save as text file. Okay, so this file I am saving, you take it as text file and save. If you give it, the program will be saved in that folder in a text file format. Okay, similarly, if you want to perform a second operation or second other operations, then you go to file, select file, take new. Once you take a new, see, you will get a blank sheet once again. Once again, you have to write your programs here based on the type of operation you are performing, whether it's a step turning, box turning, whichever the type of operation you are performing, that you have to take care here. Next, I will show. So after facing, I'll show the step turning cycle. Okay, so which one is step turning? This one. So I'll show the sketch and I'll rewrite it once again. So I'll execute this one. Okay, step turning. The diameter of the workpiece is 30, length, add these 3. 20 plus 20, 40 plus 35, 75. So dia 30, length 75. Okay. Sorry, I'll copy the program. So this G28 and all these things will come at the end. Here I have a space shortage. That's why I've taken like this. Okay, so I have written my program here. This is step facing cycle or turning cycle. Okay, step turning cycle. So same procedure. First, take a blank, length of 75, dia of 30. Okay. Next is machine. See, this is icon oriented. We have a say this one will give in a text manner. If you click on blank, you will get this command. Okay. Next, after instead of clicking this icon, if you click on machine, it will type shows the which type of machines we have. Select Fanuc. Yeah. Next, I'll go to syntax. See here, if I click on syntax, it will do the syntaxing. Next, immediately once the program is correct, automatically it will take to the tooling environment. So click on this one, assign tool. So once again, we are doing the external turn. Take a turning tool, so you can edit the tool geometry. If I didn't edit the tool geometry, just observe what happens. Okay. So previous I have edited given the nose radius as 0, but in this case the nose radius is 0.8. I am taking as it is. Just observe what happens. Okay. So next I'll give simulation. So here also see, click on simulation. First is line mode, means line by line it will give the instructions. So I'll run the line mode here. Just observe. Line mode means previous is a solid configuration, line mode. So in this case I'll give play. See here. So I'll reduce the speed. I'll give once again play. See, tool comes here in the X depth, go to initial position, come back once again X in a depth, it will go back, finish it. So I think you can make out now. So this is line by line or line simulation it is. Okay. If you want to change the simulation, a solid mode, select the solid mode. Okay, give play. So it will give the instructions here. See here, X coordinate, Z coordinate, spindle speed, feed rate, so spindle rotation, everything will be displayed here. See, if I didn't give that radius 0, you can make out here. You are getting a radius here. Okay, so I'll make up the simulation faster. So here, the tool radius has been maintained here. So if you want to remove this one, we have to remove the tool radius. Here, go to this tool, click on tool, click on the tool again, assign tool, go to external turn. Okay, select the tool, edit tool geometry. Here you have to change it as 0. Okay, give OK and OK. Give OK. So after doing this, give play. So once again, it is taking the same radius. So whatever the changes we make, after making any changes, we have to run a syntax. Then only the changes will be modified in that program. Okay. So go to blank, the same thing, machine, same thing. Next, syntax. Then go to tool, external turn, assign tool, edit tool geometry. So already is there. By directly giving the tool edit geometry 0. Okay, okay, okay. Next, simulate. So here now we can see that. So if you take the radius tool nose, you will get a that much radius will be maintained here. Okay. So based on the condition, based on the problem, you depending on the type of program you are executing, change the tool parameters. Okay. Similarly, next I'll show G94 and G90 cycle. Right. So this one. So step turning, simple step turning we have done now. Next I'll show using G94. So step turning using G94 cycle. So I'll copy this program. So I'll write a dia of the workpiece and length here itself. Dia 30 mm and length is here itself I'll take length is 15. Okay. So I'll copy this program. So I'll share it here. See? Here. Delete. So I'll take my new program here. Okay. Or else what we can do, go to File, New. So I'm not saving once again. Already I've shown how to save that file. So once I've taken new, I'll paste my program here. Okay. So dia and length I have taken here. So go to blank. Dia is 30, length is 15 mm. 15, dia 30, give OK. So once the billet has been taken, machine. So you can go by command or icon oriented. Both you can use. I'll take machine as a funnel. Next, I'll do the syntax check. So most of you may ask, sir, how to know the errors in the program? See here, warning we can see here. Warning invalid code of dia 30. Warning invalid code of mm. Warning invalid code of length 15. Warning invalid code of mm. See, because these are the things I have taken here. So it will check this one. This instruction is not with respect to machine. So if it is an error, we cannot run. If it is a warning, we can run the program. So I'll delete this and I'll do once again syntax. See, now all the warnings has been removed. So if there is an error, so I'll give, see, instead of taking G00, I'll write some G100. Okay, so G100 we don't have. So I'll do the syntax check. See, invalid code G100. Understood? So I cannot perform. So G00 absolute. So next is x minus 30, it will take the value, it won't give an error. So instead of 00, I'll write OO, capital letter or alphabet OO. Now I'll do the syntax check. See, invalid code of G00. So it is giving a warning. Still it will run, but this program will not be read. Okay. So this is how the errors will appear. So take 00. So once if you make any changes in a program, you have to run a syntax. If you didn't run a syntax, that will not be recorded. Okay. So next, assign tool. External we are doing, external term. Edit tool geometry, tool nose radius, 0, length, width, everything you can alter based on your requirement. Give OK, OK, and OK. So next is simulation. So show the differences. Play. Okay, so it has taken only one line from this one. So if I give this one, see, so I will make this speed lesser. Simulate. See, it is doing box turning cycle. So in this, what we are doing, first we are giving a depth in Z direction, then we are removing a material in X direction. Okay. So it will finish and will go out. So reference point and it will go to home position. So this is box turning cycle. Okay. So next, using G90 cycle. So I'll go to share once again. I'll take this program. See, I've taken this one. Now I'll take this one. Step turning cycle using G90 cycle. Okay. So just remember the dia and other things. Dia 30, length of 25 plus 25, 50 plus 30, 80. Dia 30, length 80. So I'll copy the program. So I'll go to share, I'll take my NC program. Okay. Here once again file, new. So if you want to save, give save. Okay, I am not saving every program here, I am just showing how to execute. So you have to save every programs after completion. Okay. So I'll take a new one and I'll paste my program here. So next, same procedure. First blank, length of the blank is 80, dia is 30, give OK. So I've taken my dia. Next machine, Fanuc type, select. Next, syntax. So assign tool, external turn, edit tool geometry, clear this nose radius to 0. Okay, okay, okay. So if you want to assign second tool, see here I have not taken any second tool here. So that's why only one tool I'll give okay. So in future programs I'll show how to add another tool and how to simulate that one. So next, once tool has been taken, simulate. See, now we are giving in, remove the material in Z direction. X in Z in depth, remove X is the depth of cut, Z is length of the material has been removed. Okay, this is step turning cycle using G90. So we have finished this one. So next is Cannon cycle we used to call Cannon cycle or multiple turning cycle. So in this what we'll do, we use a command called G71 and G70. So G71 for rough turning, G70 for finishing. So here we used to write a program in terms of point to point. Okay, after writing that point to point program, we used to give a depth of cut and for final finishing the material to be kept. Those parameters will be assigned and we used to write a program in a single line. See, from point to point we used to write a program. From if you taken this as P1, P2, P3, P4, P5, P6, P7, P8. Okay, these are the points. So for this one, I have taken a sequence number here. See, N1, N2, N3, N4. Means N1, N2, N3, N4 is the points at dimension at these points. So before that, first I'll explain what is G71, G70. See, G71 is a rough turning cycle. We used to give it in two lines. In first line, G71, U an incremental value, a depth of cut. So 0.5 is the depth of cut for every cycle. Okay, once it will take, once it's carry out the process, after finishing a single path, then it will take a once again 0.5 depth of cut, then it will continue that profile till it finishes the last point of the profile. Okay, so this G71 U an incremental value is a depth of cut, means every depth 0.5 material has been removed. So we can vary this one 0.5, 1, 1.5. We cannot go behind 2 mm because maximum depth of cut we can give for any machine is 1 or 1.5 for rough turning. Okay, so next in second line, G71 P and Q. So P and Q are the sequence code references. See, P1 means starting point of the program, Q means end of the program. So we have taken with respect to N1 to N8. So if it is two more lines extra, if it then it is N9 and N10, then it is P1 and Q10. And these are the two materials. Depth of cut has been left for the final cut, means in X direction and Z direction. So for finishing, we have kept a material of 0.5, 0.5 in X and Z direction. You can vary this one. Okay, for generally for finishing, we used to keep a micron level material. So we have taken 0.5 and 0.5. Then feed rate is 50 we have taken. So next I will write a program in terms of point to point program. So if it is P1, okay, in N1, G01, X5, Z0. So X5 is the diameter is this one, Z0 means tool come to this point and stop. Next N2 means up to this point. So X10, Z minus 10. See here, dia of the workpiece is 10 at this point and length is 10, X10, Z minus 10. Then from this point to this point, Z minus 15. So I added this here. Next Z02. So this is clockwise interpolation. Okay, and this one is anti-clockwise. G02 clockwise interpolation. So I'll explain this line also here. G02 X20 means the diameter of the workpiece at this point. So at this point it is X20. Okay, next Z depth up to this point. So from this point you have to calculate 10, 15, 25, Z minus 25. Radius at which it has to follow. So it is a radius it has to follow. If it is given R10, I will give R10 here. R8, R11, whatever the radius is there, that radius you have to give it here. Next, feed rate. Okay, at what speed the material has been removed. So once I finish this point, then I'll go to G01, once again linear interpolation, Z minus 30, I'll come to this point. After coming to this point, this is anti-clockwise. Okay, this one is anti-clockwise. So I'll taken G03, X25. So maximum point X has to reach up to dia 25. So that is X25. Z minus 40 means up to this point. So you can calculate 10, 15, 25, 30, 40. Okay, Z minus 40. See, previous I have given R10. For this it is R7. So we have taken R7 here. Feed of 50. So next G01 linear position up to this point. I'll give Z value minus 45. Next I have to do the taper here. For doing a taper, X and Z will be given in a same line. So X30, Z minus 50. So once I finished here, so I'll go to finishing cycle. G70. Once again, sequence number P and Q. Okay, P1 to Q8. So here I have not taken any, this one means I have taken an absolute value 0, 0. No material will be left. This is the material left in a rough cycle. Okay, for finishing, I am removing this material in X and Z directions. Okay, so that will be, that's why G70, P1, Q80 at a feed rate of 50. After finishing this, it will go to home position. Okay, using this command, spindle of program end. So I'll tell you how to execute this program. Just remember the dia and length of the workpiece. Dia of the workpiece is 30. Length I can give it 100, no problem. Only this much it will be removed. Dia 30 and length 100 I'll take. So I'll copy this program. Control C. Once again I'll go to CNC simulator. I'll share a screen. Okay. Share CNC. So once again, I'll go to File, New. So if you want to make any changes, save, give yes here. So same, where we are in desktop, I have one folder, right? Rajiv. You go to Rajiv, open. So instead of giving entitled, I'll give it as step turning. So this is how we have to save. So okay, once I save, I'll get a new one. So I'll paste my program here. So you cannot post it here. See, I've taken a single tool here. I'll show how to add another tool and execute the program. Okay. So first I'll run in a single tool. Next I'll tell you how to add the another tool. So blank, the length of, you take 100, no problem. Die of 30. Okay. Machine, the Fanuc type, select A. Then syntax, check syntax, no error. Assign tool, external turn, tool radius 0. Okay. 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 So next I'll give simulate. See, it has taking a depth of cut of 0.5. You can see here coordinates. So this is G71. See, last one is G70. So final depth of cutter, what we have left. So I'll change a program here. I'll add one more tool here. G28U0W0. Enter. So M0, like caps, M03, T0202. Okay. So this I have to remove, I'll tell you. Next. So it will go to home position from the reference. It will change the tool. It will come back to this material. So check what if I come across with any error or not. So once again, G28, U0, W0, M05, M30. I've changed my program. So you have to run a syntax once again. See, I've added one more tool here. So previous it is only one tool. So for finishing, I've taken one more tool. This tool is already assigned. Don't worry about that. You go to click on second tool, assign tool. Once again, it is external turn. So edit tool geometry, radius 0. Okay. 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 So next simulation. So here I'll give up to next tool. Play. So it is doing G71, rough turning cycle. See, first tool it has been finished. For second tool, it has been stopped here. Okay. So next, end machining. See, new tool has been taken and it will be finished. So this is how we can add multiple tools. Understood? So I have another one program. It is for growing cycle. Just I'll show that growing cycle for you. So after that, in next class, I'll show how to do drilling and milling operations. Okay. So I'll stop screen sharing here. We'll go to share. I'll take up this one. See, last program is this one. So in this case, I've taken both. Okay. So G71 and G70 along with parting tool. Both I have taken. So I'll copy this program. And I'll paste it. Okay. So I'll go to File, New. I don't want to save any changes here. Control V paste. Okay, another half is there. We'll take a. So I've taken this program. So for this, dia is once again 22 and length of some 80 I'll take. Same blank 100 length, dia of 32, it is 22. Okay. Machine, Fanuc, select, syntax. See here, I don't have assigned any tools here. So first one is turning tool, second one is grooving tool or parting tool I have to take. So okay. So first I'll take turning tool, assign tool, external turn, edit tool geometry, radius is 0. Okay. Okay. Next is click on second tool, assign tool. So here, see here, external groove. This we have to take. Click on this mark, external groove. So I'll take width of the tool as 4. Okay. So I'll go to edit tool geometry. Width of this tip I'll take 4. I'll tell you why. From the left, okay. And I'll give okay. From left it will take. Okay. So I'll give a simulation now. Say first it is doing G71 and G70. Okay, it will do the step turning or profile turning. After that, using last tool, it will do the grooving. Okay, tool change, grooving cycle. So why I have taken that width of the tip as 4 means the width of this groove is 4 mm and width of this groove is 5 mm. Okay, without the lesser width is that we have to take, because in one stretch itself I can remove this one. Then in this case, I have removed material up to this point. Then I give Z in 1 mm direction. Okay, and it will remove 5 mm here. So this is how we can perform a simulation using CNC turn. I hope all you have understood. Thank you.